Why not?
Why? Can you tell me why?
Because that's what I picked.
So can you change it?
No.
It's high, but
It's not high. All right, so picking up from, or just to remind you quickly what we were doing in the last lecture, we were talking about loops.
Another thing, did you talk about missing any quiz?
Sorry. If you can miss one quiz in this course without penalty. So you miss the quiz, the weight moves to, I don't remember where the weight moves to. It either moves, I think it moves to the exam.
So for the last semester, I did my exam and didn't put a mark, it didn't change the mark. It's down to 65, not 60.
I did not post the exam marks.
Why?
If you want to ask these questions, ask them during office hours, please.
You shouldn't do that.
Please ask them during office hours. All right, so just to remind you where we were, what we were talking about in the end of the last lecture. We were talking about loops, right? And so Java has a for each style loop that's similar to the Python for each style loop. The syntax is a little different. Right? Now in Java, you can't write a for each loop for everything, right? You can make one for an array, and you can write one for other things we haven't talked about yet. Right? But there are some things in Java where you would like to write a for each loop, but you can't. Right? So for example, when we talk about strings later in this lecture, you're going to see that you cannot write a for each loop over a string in Java, which is strange because in Python you can. Right? And so you have to be a little bit careful when you use Java's for each loop. Right? So the for each loop in Java, right? The way you read this one is for each double for each double value called elem, in the array ARR, right? So there's a variable declaration here, right? The type of the variable is whatever element type ARR has, right? And then there is the thing that you want to loop over on the right-hand side, right? So in this case, we want to loop over the array ARR. So there's your for each loop in Java. Now Java also has a counting style loop, right? And so this is the, I guess, the traditional or the conventional, or I guess just a for loop in Java. Right? The for each loop was actually added into the language. It wasn't there to begin it wasn't there at the beginning of the language, right? So the language originally started with this counting style loop. So in the counting style loop, right, typically you create a loop variable here, right? Usually it's an int of some kind, right? Because normally you're using an int which you count. It doesn't have to be, right? It could be something else here, but normally it's an int, right? Then there's a semicolon. Then there's what's called the termination condition. So the termination condition determines whether or not the loop runs. Right? So as long as I is less than the length of the array, the loop body will run. Right? Then there's a semicolon, and then finally there's the loop update expression. Right? So the loop update expression runs right there. So at the bottom of the loop, every time the loop runs, the loop update expression runs. Right? And so I++ means take the value of I and increment it by 1, so add 1 to it. And so that's the regular or the counting style loop or the C style loop or just a for loop in Java. Okay, so if you can use the for each loop, then you should use the for each loop because it's much easier to write. It's also slightly easier to read. But there's many circumstances when you cannot use the for each loop. Right? So for example, if you, the for each loop only lets you access one element of the, in this case, the array at every loop iteration. If you need to access more than one element of the array, then you probably want to use a regular for loop. Right? So to test if an array is in sorted ascending order, right? So from smallest to largest, right? You want to look at the first and second elements of the array, right? And check if they're in the correct order. If they are, you want to look at the second and third elements of the array, and so on and so on and so on. Right? So in each loop iteration, you want to look at 2 elements of the array. Right? And so for this one, I'm going to start at index 1, so the second element of the array. Right? I want the loop to run as long as the index is less than the length of the array. Right? Each time through the loop, I'm going to add 1 to the index. Right? So inside the loop body, I just want to compare the previous element, which is at index I minus 1. Right? And I want to compare that to the current element, which is at index I. Right? And so that I minus 1, right, if you start out with I being equal to 1, right, then that's equal to 0, which is the smallest legal index in Java. Right? And so this one correctly starts at the beginning correctly compares the first element to the second element, then the second to the third, and so on and so on and so forth. Right? So if you ever find a pair of elements that are out of order, so if the previous element is greater than the current element, then you know the list is not sorted. Right? So you can, in this particular example, I'm going to set the variable is sorted to false, and then we're going to continue with the loop. Right? So the loop is going to process all the elements of the array, even though you already know that the array is not sorted. Right? So this is a picture of what's going on. Right? So when I is equal to 1, so iteration 1, it compares the first two elements. Right? Then the next two elements, and so on, and so on, and so on. Right? So there's 16 elements in the array, so the maximum element is 15. Right? So Java has a break statement, just like Python has. So if you want to escape or break out of a loop, right, you can use a break statement. The break statement breaks out of the loop, the innermost loop that it's currently in. Right? So this break statement is inside this for loop, so it breaks out of this for loop. If you write a nested for loop, right, then the break statement breaks out of whatever loop it's in. Right? So if it's in the innermost loop, it breaks out of the innermost loop, but the outermost loop still runs. That's also the same as Python. Right? And if you know about the Python continue statement, then Java also has a continue statement. Right, so this example here, when we see the elements 99 and 15, right, we know that the array is not sorted, so we can stop iterating over the elements of the array and break out of the loop. Okay. I guess also here, right, in this particular example, you can also immediately return false, right, instead of setting a variable and breaking out of the loop. Right, so a return false also works here. Now, you have to be careful when you write that sort of code, right? Because it's very often what you'll see is that new programmers will test the opposite condition. So they'll test is array I minus 1 less than or equal to array I, right? And if it is, they'll return true, right? So they will return true incorrectly. They'll do it before they actually have processed all the elements of the array. Right, so if you're gonna return out of a loop, you have to make sure that you're actually solving the problem you're trying to solve, right, and not returning prematurely. All right, here's another example of when you where you want to access more than one element of the loop at the same time. More than one element of the array in every loop iteration. Right. Again, this is another example of a loop that is inconvenient or awkward to write using a for each loop. Right? And so using a counting style loop, we can determine whether or not, we can reverse the elements of an array in place. Right? So to reverse the elements of an array, you just switch the first and last elements of the array. Right? Then you switch the second and second last elements, then the third and the third last elements, and so on and so on and so on, until you reach the middle of the array. Right? And so the way I'm going to do this is I'm going to use two indexes. Right? I'm going to use I to indicate the element at the front of the array. I'm going to use j to indicate the element in the back half of the array. Right? So I is going to start at 0. Right? J is going to start at the length of the array minus 1. Right? So that's the index of the last element of the array. Right? How long do I want this to run for? Well, I want this to run as long as I is less than j. Right? So in other words, as long as I'm swapping an element from the front half of the array with an element in the back half of the array. Each time through the loop, I want to increase I by 1, right? So I want to move I 1 position to the right. Similarly, I want to move j 1 position to the left. So at the end of the loop, I'm going to decrement j, right? So j minus minus, subtract 1 from j and assign it back to j, right? Each time through the loop, I'm just going to swap the elements at index I and index j, right? So to swap, right, if you've done assignment 1, you've already done this. Right? You make a temporary variable, you store the element at AI or AJ, right? If you store AI here, you're going to set AI on the next line, right? So you set AI to whatever's in AJ, right? And now you can set AJ to whatever used to be in AI, right? That's why you need the temporary variable, right? Because you overwrote the value of AI here, right? So if you don't use the temporary variable, you don't have the original value of AI, right? You now have the new value of AI, which is not what you want. Right? In Python, I think you can do an assignment with tuples, and you can do the swap in a single line. Can't do that in Java, unfortunately.
Which note is this?
Number... Lecture slide set 4. Right. Okay, so there's another example of where, when you're accessing more than one element at the same time, you probably don't want to use a for each loop to write this loop. Right. Now, you can improve this slightly. Hello? Here we go. Okay, so this is a picture of what's going on. Right, so the first iteration of the loop, I'm going to swap the first and last element of the array. So I is 0. Right, j is the length minus 1, so it's 15. Right, switch the 27 and the 12, and then move on to the second and second last elements. Right, so I is going to move this way, j is going to move this way. Right, you keep on going. Eventually, you end up here. Right, so I is still less than j, so I still want to switch the 19 and the 20. Right, but after I do that, j ends up over here, and I ends up over here, so you want to stop. Because if you keep on going, you're going to unreverse the array. Right? You'll start to switch back elements that you previously switched, right? And then you stop there. Right? Okay, so in that example there's actually two loop variables, right? There's an I and a j, and they're both ints. And so Java lets you write the for loop using more than one loop variable. Right? You can only do this if they have the same type. Right? And so I can combine I and j into the loop part up here. Right? So I can declare a variable I and set it to 0. Right? Now here I can use a comma and write j equals the length minus 1. So that actually creates two variables, right? It creates I and j. Right? It sets I to 0, sets j to the length minus 1. Right? My termination condition is still I is less than j. Right? Now in the update expression, right, I can update I and j, right? And I separate those two expressions with a comma. Right? And so this lets you put everything into the loop part itself, right? Rather than updating j in the body itself, right? Like we did back here, right? And so you can do it this way. All right, so if the loop body must, again, so if you have to access, so if you're accessing more than one element of the array at the same time, or if you're accessing elements from different arrays in every iteration, right? Again, you probably have to use a regular counting style loop. So here I want to sum the values stored in A with the values stored in B, right? So I want to compute A0 plus B0 and store that in a new array. Then I want to compute A1 plus B1, store that in a new array. So these might be, for example, mathematical vectors, right? These are, well, they're not quite vectors. They might be the representation of a pair of mathematical vectors. Right, so now I'm accessing elements in A, B, and in C, right? The returned array. So I'm going to return the array C containing the sum of the elements. Now I'm accessing elements in 3 arrays in the same loop. So there's no way I can write a for each loop, right? A for each loop only lets you access elements of a single array. Right? And so I write a regular loop, so starting at index 0, going up to but not including the length, right? And I just set ci equal to ai plus bi. Right? Of course, in this example here, you really should test if a and b have the same length. Right? If they don't have the same length, that loop is going to fail at some point. Right? So for example, if a is shorter than b, if a is longer than b, right, then eventually you're going to reach a point where you're trying to access or use an index in B that's not valid, right? And that will throw an array index out of bounds exception there. So here, yeah, so there, the assumption there, you really should test with an if statement. Okay, what about slicing? So you can slice a Python sequence, right? And it's actually super handy to do so in many cases. Right? So a slice in Python lets you access a contiguous sequence of elements from the original list, right? So in Python, you say you get a sublist from the original list. Right? So if your list is the elements 10 through 15, right, then the slice 2 through 5 means starting at index 2, going up to but not including index 5. So indexes 2, 3, and 4. Right? So that returns the sublist consisting of indexes 0, 1, 2, 3, and 4. And returns a new list. right? So you get the new list containing those 3 elements of the list. Right? And of course, you can slice from the front, you can slice from the back, and whatever you want in Python. So in Java, there is no slice operator, which is unfortunate, but that's the way it works. Right? Now, if you want to, you can write your own function that slices an array. Right? It's not terribly hard to do. Right? I want to use the same syntax as with the Python slice, except I don't have negative indexes. So you have to keep that in mind. Right? So here, my method slice takes in an array to slice, right? It takes in the starting index, and it takes in the stopping index, right? So start in this example would be 2, stop is 5, right? So the stopping index does not include the last element. The stopping index, the slice goes up to the stopping index minus 1. Right. All right. So in Java, you want to make sure that the start index comes before the stop index. Right, so you want to make sure that start really is you want to make sure that start is less than or equal to stop. Right? So if start is greater than stop, you want to throw an exception to indicate that there's an error. Right? You should test other things as well. Right? There's at least one other condition you should check. Right? The other condition you probably want to check is do you want to make sure that start is actually a valid index for the array. Right? So in other words, you want to test if start is you want to test if it's less than 0, or you want to test if it's greater than or equal to the length of ARR, right? Because if it is, it's not a valid index, and you want to throw an exception. If you test here, you don't also have to test stop, right? Because that condition there is sufficient, right? If you know start is a legal index, then here, right? Then here you also know that stop is a legal index. Oh, sorry, that's not true. You have to test if stop is less than or equal to the length of the array. Okay, right there you want to create your array to hold the slice. Right? So how many elements are in the slice? Well, it turns out it's stop minus start, right? Which you can easily confirm. Right? If you go back to the example, right? This slice here contains 3 elements. Right? That's just 5 minus 2. Right? As long as the indexes are positive, you can always calculate the length of the slice just by subtracting the 2 indexes. Right, now you want to fill in this array slice, right, by copying the elements from the array ARR. Right, so I want to start copying the elements from ARR at index start. Right, so I is going to be my index for the array ARR. Right, so I want to start at start. Right, I want to stop 1 before stop, so as long as I is less than stop. I want to grab the element at that index, right? And now I want to put it into the sliced or into the array SLC, right? Now remember the array SLC, right? Its first index is 0, right? So if your starting index is start, then the corresponding index in slice is I minus start, right? First time through the loop, it's start minus start, which is 0. Right? Second time through the loop, it's start plus 1 minus start, which is 1, and so on and so on and so forth. So perform a little calculation here to compute the correct index in slice, and then return the slice after the loop finishes running. Right? Once you've got your slice method, you can call it just like any other method. Right? So for example, right, if you have an array T, right, that's the same. That's the array consisting of the same elements as the Python list I showed you a few slides ago. Right? And then you can slice that array using our slice method now. Okay, now this is, I guess this is a semi-interesting exercise, right? But you have to remember that the language doesn't actually have this method for you, right? If you want to do this sort of thing, you have to write the method for you and then put it in a class somewhere. You probably have to import the class to use it in your program, right? But it's not part of the standard libraries in Java. Yeah?
Is the reason that the standard library includes a lot less features just to make it like more lightweight?
Sorry, run that by me again?
Like the reason that why Java has, I guess, less functions that we can manipulate arrays and whatnot.
Oh, I see. So I think in this particular example, I think the answer is that when they created the language, they didn't think that slicing an array would be a useful enough operation to include as part of the functionality of a regular array, or to include as a separate method somewhere in the standard library. It does turn out to be handy in Python. One of the reasons why you don't want to do this slice all the time, right, is because it's actually expensive if you do this over and over and over again. Right? So when you look at what's involved in the slice, right, there's the creation of a new array, right, which occupies memory. Right? Then there's iterating over the array, which takes time. Right? If you are slicing large arrays over and over and over again, this becomes a very expensive operation. Right? Okay, what about copying an array? So in Python, you can copy a list just by slicing it. Right? So t square bracket colon means make a copy of the entire, or slice the entire list t and return a copy of that slice. Right? And so you get a copy in this case. So that's handy. Right? In Java, you could also use slice again to copy the array. Right? So there's slice. Now, if you wanted to slice the entire array, you would use 0 and t.length. Right? However, there's also a clone method. There's a clone method in Java that every array knows how to perform. Right? So t.clone will successfully make a copy of a one-dimensional Java array. Right? Now, I haven't told you about two-dimensional arrays. They do exist. Three-dimensional arrays exist. So multi-dimensional arrays exist in Java. Right? You cannot, clone doesn't do what you want it to do if you have a multi-dimensional array in Java. Right? So you can safely clone a one-dimensional array in Java. If you clone a multi-dimensional array in Java, what you get is not exactly what you want. Right? And so make sure that if you're going to use clone, you only do it on a one-dimensional array. Or if you do it on a multi-dimensional array, you actually understand what it does when you use a multi-dimensional array. Yeah? Yeah, so it gives you an array where each element of the array is an alias to another array. So if you modify the clone, now you modify the original as well. Yeah. More precisely, if you modify any of the elements of the clone, you modify the element in the original as well. Yeah. Was that the same question? There was a second hand up. Okay. All right, so that's arrays in Java, arrays and loops. So that definitely gets you set up for assignment 1. You probably didn't need to know everything here for assignment 1, but that'll definitely get you through assignment 1. Right? Assignment 1 is just working with one-dimensional arrays in Java.
You didn't call the PA office hours.
They're not on OnQ yet, but you should have received an invite over Teams. Right? You all got a Teams invite, right? Like 8 of them? Yes. Oh, yeah. Sorry about that. But there's the only way I can do it. So I can't. There's no easy way for me to just send you one invite for all the lab hours. All right, moving on. So now we're on lecture deck 5. Oh, there's Monster Train. Okay, so using strings in Java. So strings in Java are, I guess there's some similarities to Python strings, but there are some pretty significant differences as well. Now, the nice thing is that both languages actually have a functioning string class, so that's nice. Right? If you take Sys 220, you're going to run into the language C. C does not have a string class.
What's
right?
the other language in 220? What's the other one?
So you would also do a scripting language called Bash. Bash does have strings, but in C, you just have arrays of characters. And so that becomes really annoying if you want to use them as actual strings. Right? So in Java, and in Java, a string literal is a sequence of characters between double quotes. Right? So double quote, rub-a-dub-dub. Right? So that makes the string rub-a-dub-dub. Right? The string object, a reference to that string object, is stored in the variable s. Right? Now, this is the first difference between Java and Python. Right? So in Python, the individual characters of a string are themselves strings. Right? In Java, the individual characters of the string are these things called char. Right? Little c, char. Right? So it's a primitive type variable. Char is actually a number. right? So the type char actually is a numeric type. So it's an integer numeric type, right? They just happen to look like characters. So I'll explain that in a second. Right. So like in Python, a string, you can consider it to be a sequence of characters, right? But you can't use the square bracket notation to get to the elements of the string. Sorry, what's going on? Okay. So if you want to get to an element of the string, right, if you want to get to an individual character of a string, right, you have to use a method. Right? So first of all, you need a string reference. So I need a variable s, right, in this case, right? I need to use the method char@. And now to call the method, it's s.char@. So I'm asking the string object named s, right, for its character at element 0. Right? So this is a method call right there. So you need round brackets here, and you need to pass in the index here. Right? It's not the square brackets. Right? The elements of the character of the string, are of type little c char. Right? Not of type big S string, which can also be inconvenient in some cases. Right? Okay, so what are these things called chars? Well, it turns out they're actually numbers. Right? You also have char literals. So a char literal is any single character inside of single quotes. Right? So single quote, and there's an A. Right? So in this case, we have the char literal A. Right? There must be exactly one character inside the quotes, right? Which is almost true. It's almost true. You can actually use more than one character, but you have to do it in a special way. I'm not going to tell you what that actually does. Right? So you can store a space in a char. That's fine. Right? So just a blank space is the space literal. Right? You can't write single quote. Right? There has to be a character in between. So there is no such thing as the empty char. Right? There's an empty string. There's no empty char. So chars are integers. So they start at 0, right? And they go up to, well, roughly 65,000. Right? And so the char number 0 maps to some printable character. Well, not necessarily. It maps to some character, right, or some symbol. Right? The char number 1 maps to some other symbol. The char number 2 maps to some other symbol, and so on and so on and so forth. Right? It turns out the char whose value is 65 maps to the uppercase A. Right? So the mapping is defined by this thing called Unicode, right? And it's one of the many versions of Unicode that Java uses for this actual mapping. So Unicode is the standard, is a standard for representing characters or symbols that people use. Right? The idea behind Unicode is that we should be able to represent every symbol across all languages on the planet Earth. Right? And so there's a lot of them, right? In this case, there's 65,000 something, right? Which I don't think is actually sufficient to hold all symbols for all languages used. But anyway, part of these characters, there are things like emojis and things like that, right? So there's all sorts of funny figures and things like that. Right, but these are all single printable characters. Sorry, not necessarily printable. Not all of them are printable. Right. All right, so 65 corresponds to uppercase A. If you print a char, you get the printed version, right? You get the symbol. You don't get the numeric value. Right? So when you print C, in this case, you get A, not 65. Right? Now, they're just integer values, so you can do arithmetic with them. So for example, I can add 25 to C. Right? Now, if you add 25 to C, you get 90. But you also end up getting the letter Z, right? Which is not surprising, right? If you start out at A and you go 25 characters, I guess, to the right, you end up at the Z, right? 66 is B, right? Uppercase B. 67 is uppercase C, and so on and so on and so forth. Right? So you are allowed to do arithmetic with char because it's an integer type, but the results are very strange. And I recommend you, if you need to do arithmetic with char, you be very careful when you do so, right? So the results are super unintuitive, especially when int values are involved. Right? So I can start out with the char A, big uppercase A. Right? I can write C++, right? Remember what C++ does? Add 1 to C, right? So that changes C to from 65 to 66, right? And now you get the uppercase B if you print it. You can use plus equals, right? So just like in Python, C plus equals 1 means take 1, add it to C, and change the value of C, right? So that now gives me the uppercase C, right? Or the int value 60, or the integer value 67, right? Minus equals 1, so now we go back to 66, which is the B again, right? Now you might say, well, look, that line there is essentially equivalent to that line there, right? Mathematically, that's true. In a programming language, it's not true, right? That plus equals is a different operator than the equals and the plus operator applied to two values, right? And so the way that programming languages evaluate these is not necessarily the same way you would evaluate these mathematically, right? And so now you get an error, right? So you've actually tried running this in Java. Hopefully I still have this up from yesterday, right? So if you actually try running this in Java back here, let me just comment out this part down here. Okay, so up here we start out with A. Oops. Okay, here we go. Then we add 25 to it, so I'm just going to show you, this is from a couple of slides ago, right? So we get A then Z, right? Now if I uncomment out this block here, like that. Oh, sorry, I have to fix this too. Put this back to that. Okay, and now you get this error here, right? So Eclipse underlines it in red and it complains. It says type mismatch cannot convert from int to char, right? And you say, well, that's weird, right? Chars are just integer values. Why can't I add these? Or why, when I add these, do I get an error? And the answer is, right? So when Java sees an expression that looks like that, right? It looks at the types of the operands to determine what operation to perform, right? So C is a char, but 1 is an int, right? And so the rule in Java is if you do arithmetic with mixed types, right? The smaller type gets converted to the wider type, right? So char is smaller than int, right? It represents a smaller range than int. So that char value gets promoted to int, right? So you now get 65 as an int plus 1, which is 66 as an int, right? You cannot store an int in a char, right? So ints are wider than chars. The language doesn't let you store a wider value in a narrower value, right? So can't store an int in a char, and so that's why you get the error, right? Now, if you happen to know that C plus 1 does not overflow the range of char, right, you can tell the compiler, hey, treat this value as though it were a char. That's called a cast in Java, right? So you can make this error go away by taking the value of C plus 1, right? So I want the entire value of C plus 1, right? I want the sum, right? And I can tell the compiler, hey, treat that value as though it were a char using a cast, right? And so that right there is an example of a Java cast. Right? Inside round brackets, you put in type, right? And then that tells the compiler to try to treat the value to the right of the cast as though it were the type inside the round brackets. Right? So that casts the int value to a char value, right? You can't you cannot arbitrarily cast one type to another type, right? You can only cast compatible types. So you can cast from one numeric type to another numeric type, right? Usually casting from a reference type to a different reference type doesn't work until you know more about inheritance in this course that we'll learn about in week 6 or 7 of the course, right? So if you're going to try a cast, make sure you're doing it with the primitive types for the time being, right? Later on, we might see casts using reference types, right? But you can't, for example, cast C plus 1 to a string, right? That's guaranteed not to work, right? In fact, you can even try it right here, and the compiler will complain, right? So now it complains, and it says type mismatch cannot convert from string to char in this case, right? Whoop, like that. All right. Was there a question? Sorry, no? Okay. All right, so that doesn't work. That's great. We can fix it by using a cast. Now, it gets even stranger, right? I can start with a char D, right? So I'm going to set that to B, right? And I'm going to try to add C and D, right? Now that's a char and that's a char, right? If you try this, right? Back here, again, the compiler The compiler complains, right? This type mismatch cannot convert from int to char. Okay, so why is this complaining now, right? So you apply the rules that I just told you about. Well, that's a char and that's a char, right? If what I told you was accurate, you would say Java uses char arithmetic to compute the sum, right? And the answer is that's not what Java does. Right? So if you do arithmetic with any type that's smaller than int, Java automatically promotes everything to int, right? So if you try to do arithmetic with byte, char, or short, all of that gets done using int arithmetic, right? So that C gets converted to an int, that D gets converted to an int, the sum gets computed as int, and now you have the problem, can't store an int in a char variable, right? Exactly why the language does it that way, I'm not 100% sure. That was the way the language was designed, right? If you actually go and read the Java language standard, it will tell you it does exactly this when you do arithmetic with things like char, byte, or short, right? So that looks like it ought to work. It doesn't work. All right, now you might ask, well, when on earth do you want to do arithmetic with char, right? It's occasionally useful when you are computing strings, usually in some sort of alphabetic order, right? So for example, if I want to compute all the strings, all the two-letter strings that you can write down with uppercase letters, right? So AA, AB, AC, all the way through ZZ, right? You can easily do that given that, because chars let you do arithmetic, right? So you just write a little counting loop, right? So you start at the A, right? I want this loop to run as long as the variable C is less than or equal to the Z, right? Each time through the loop, I want to increase C by 1, right? So A, then B, then C, and so on, all the way through Z. Right? Now use a nested loop to do the second character, right? So it's exactly the same thing. Start at A, go through to the letter Z, right? Inside the loop, compute the string made up of C followed by D, right? So inside the loop, make a string S, right? I'm going to start with the empty string, right? I'm going to concatenate the character C followed by the character D onto the end of the empty string. Right? So this is string concatenation, not char arithmetic, right? Why? Because that's a string, right? String plus anything is a string, right? So that's a string, right? Now string plus anything is also a string, right? And so the behavior of the plus sign depends on the types that you're using, right? Because the string comes first in this case, everything is done using string concatenation, right? Now, be careful when you do this sort of thing. Right, so that's the code as it's written on the slide. Right, we run that. Yes, please. Oh, what's my mistake? What am I doing? Oh, sorry. All right, run that, and if you look at the output here, right, you do in fact see, well, it ends with anyway, all the two-letter characters starting with a Z, right? If you scroll up to the start of the output, it starts with AA, right? Now, if you write this, if you accidentally write C plus D, right, and then you look at this and it says, hey, that's a string, right? It says, hey, that's an int. You can't store that in a string. You say, oh yeah, I have to do string concatenation, right? So if you now write plus the empty string at the end, right? You now get a even more confusing result, right? You now get a bunch of numbers popping out, right? And so now what's going on, right? So again, right, when Java sees this kind of expression here, right, it looks at the operators in the expression and it sees it's all addition, right? So now it looks at the precedence of the operators. Right? It says, well, addition always has the same precedence, right? It's addition and addition, so they both have the same precedence. So the language evaluates the expression from left to right. So what's the left part of the expression? Well, it's C plus D, right? What is that? It's char plus char, which is int plus int. So you get an int, right? And then you add that to the empty string, right? Which is just the string representation of the int, right? Which is why you're getting all these numbers printed out here, right? If you actually do what the lecture slide says to do, put the string in front, like that, right? Now it sees two plus operators. So it says, well, everything's addition, so we're going to start at the left. Right? And now it sees string plus char. Right? So now it does string concatenation. That results in a string. Right? Then it's string plus another char. So again, it does string concatenation. Right? So the order in which you write down your operand sometimes matters. Right? In particular, it matters if you're doing string concatenation. All right, so moving on. Still talking about strings, right? But string, I need to tell you about types, classes, and objects now. All right, so what's a type? So a type is a set of values and the operations that you can perform with those values. Right? So for example, int is a type. Right? What are its set of values? Well, it's from integer min value up to integer max value. Right? What operations can you do? Well, you can do arithmetic, you can do comparisons, and a few other things. Right? A class defines a reference type in Java. Right? So all reference types are in Java are classes. Right? So for example, big S string is a class, so it's a reference type. Right? An object is an instance of a class. Right? So what the heck does that mean? Well, the number 1 is an instance of an int. Right? The number 2 is an instance of an int. Right? It's an example of an int. An object is just an instance of a class. So the string HELLO is an instance of a string, right? Or an object. Right? So if you ever see object or instance, they both mean the same thing when people are talking about object-oriented programming languages. Right? So the string A is an instance of the class string. Right? The string B is an instance of the class string, and so on and so on and so forth. Right? String is a type, right? So what are its set of values? Well, it's all sequences of sequences of characters, right? What operations can you do? Well, it turns out you can do a whole bunch of operations with strings. Right? So strings represent a sequence of characters. They're very widely used in Java programs. Right? Now, strings are a bit weird as to talk about as your first reference type in Java. To use as an example of your first reference type. Right? So because they're so widely used, the designers of the language made string look like a primitive type. Right? You can do things with strings that you can't normally do with other objects. Okay. Right? So for example, you can use the plus sign with strings. Right? There are string literals. Right? So I can put something inside double quotes, and the language says that's a string. Right? String is the only type where a literal exists for a reference type. Right? So all other reference types, there's no way to write down an example of one of those objects. Right? You have to do something else to create one of them. Right? String is the only reference type where you can do something like add, right? Use an operator with the variables of that type. Right? There's no other arithmetic or comparison operators allowed for any reference type, any other reference type in Java. You click on that link there, or you just Google Java version language, some version language string, that'll take you to the documentation for the string class. Right? And you'll see that it's actually quite big, so the strings have a fair amount of functionality. Right? So just like in Python, strings are immutable. Right? So when you make a string in either language, you can't change the characters of the string. Right? And so the sequence of characters are unmodifiable. Right? So once you make the string hello, right, the object representing the string hello is always HELL, always has the characters HELLO. Right? You can't change the characters. In both languages, anything that seems to change the characters of the string actually makes a new string object that has the change made to the new string object. Right? The original string object never changes. Right? So for example, 2 uppercase and 2 lowercase. Right? So these methods return the upper and lowercase versions of a string. It doesn't modify the original string. Right? So here's the string hello. Right? So I make the object hello, and I store a reference to that object in the variable s. Right? Now, 2 uppercase, to call that method there, you need a variable to call that method, so you need a reference. Right? And so I'm going to ask the string s, right, for its uppercase version. Right? So it's s dot to uppercase. Right? If you print out s, it's still lowercase hello. If you print out up there, right, it's now all uppercase hello. Right? So you have to, right, so that's not too surprising because I assigned the value of to uppercase to up. Right? Now what a lot of new programmers to Java will do is they'll say, hey, I need the uppercase version of S, or I want to convert S to its uppercase version. Right? And so they'll just write S to uppercase. Right? Strings are immutable in Java, so that doesn't actually change S. Right? It computes the new string all uppercase hello, and then does nothing with it. Right? Here we assigned it to up. Here we're throwing it away. Right? We're not taking the return value and using it for anything. Right? So if you really want to change S, what you have to do is you have to reassign back to S. Right? So if you write S equals S dot to uppercase, right, that computes a new string, the uppercase version of S, and then stores it back and stores a reference to the new string back in S. Right? You lose the original string in that case, right? So there's no way for you to get back the original string, little case hello, if you do that. Right? Okay, so let me just quickly go back one slide and click on this link here. So if you look at the documentation for the string class, which is actually right here, right? So when you read Java documentation, right, it's done by class, right? And so up at the top, there's a description of what the class does, right? It even tells you that they're immutable. Strings are constant. Their values cannot be changed after they're created, right? So there's a description of what it can do. Blah, 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 blah. You keep on going. We'll skip over the first two sections for now, right? And then you'll come to the methods, right? And now all the methods are documented in alphabetic order here, right? So there's char at, right? Returns the char at a specified index. If you click on the method, it takes you to the details of the documentation, right? But let's look over here in the left-hand column. Right, you see that there's a modifier and type. So this is the return value, the return type of the method. Right? If you scroll through a little bit, notice that some methods are static. Right? And so remember what a static method is. Right? A static method is a method that's associated with the class itself. Right? If I want to call this method, I use the name of the class to call this method. So if I wanted to call copy value of, right, I would write string dot copy value of. Right? If I wanted to call format, right, I would write big S string dot format. All the way at the bottom, right? If you wanted to convert a primitive type to a string, you can use the value of methods, right? They're all static, so you would write string dot value of and then some character, right? That converts the character C, or gives you computes the string representation of the character C and gives you back the string. Now, what's going on with to uppercase? Well, it's not static, right? So all you see here is the return type. It's a return type string. But the static modifier is not here, right? Non-static methods are the normal methods that you would find in a Java class, right? So it's relatively uncommon to see static methods. To call a non-static method, you need an instance of the class, right? So to call to uppercase, I need an instance of a string. Where to go? Here, right? So S is an instance of a string. So to call to uppercase, I can use S to call the method, right? So S dot to uppercase asks the object S to run its to uppercase method, right? And so so that's why I'm using a variable here, right? Instead of the word, or instead of the class name big S string, right? To uppercase is a non-static method, or just a regular method, right? You need a variable or a string reference to call this method. Right there, you require an object reference to call a non-static method, right? So here I'm using the object S to call that method, right? And it has static methods as well, right? There aren't so many of them. There are some, but there aren't many of them, right? Value of is one of those methods. Right? So if I want the string representation of the double value 1.0, you can write string dot value of 1.0. Right? Normally, if you want to do this sort of thing, it's shorter to write the empty string concatenated with the value itself. Right? And that will eventually call value of for you. Right? But it's easier to write that than it is to call value of. Right? So there's the difference between a static and a non-static method, right? All the methods we wrote, for assignment 1 anyway, or up to this point, are static. Most of the methods that you're going to write going forward will be non-static, right? To call those methods, you're going to use a reference. Yeah?
Does the second method just use the first method, like first method of without?
Down here?
Yeah.
So it's not exactly clear. So this actually does a whole bunch of things. What it's going to end up doing is it's going to take that 1.0, right? The compiler is going to call value of for you to give you back a string, right? It's now going to do string concatenation using the string method called concat. So there's a whole bunch of steps that this is actually probably calling value of, because it doesn't have to do the concatenation. Yeah. All right, so that's it for today. We'll pick this up in the next lecture.
Hey, so the sample